Welcome to this video on Chapter 9, Hydrocarbons. This guide covers the structure, nomenclature, and preparation of alkanes, alkanes, and aromatic compounds according to the CBSE chemistry curriculum. Hydrocarbons are classified into three main groups. Saturated hydrocarbons include alkanes and cycloalkanes. Unsaturated ones contain multiple bonds, while aromatic compounds consist of cyclic structures with exceptional stability. Alkanes possess a tetrahedral architecture with sp3 hybridized carbons. They are often called paraffins due to their chemical inertness, though they participate in reactions like substitution, combustion, and isomerization. Ethane exhibits two primary conformations. The staggered conformation is the more stable, preferred spatial structure. The eclipsed conformation, however, experiences high torsional strain due to repulsive forces between hydrogen atoms. Alkenes feature restricted rotation due to the lateral overlap of p orbitals in their pi bond. This limitation leads to geometrical isomerism, specifically cis and trans isomers with distinct physical properties. Regioselectivity in alkene additions is defined by Markovnikov's rule, which follows a polar pathway. Conversely, the peroxide effect, or anti-Markovnikov addition, proceeds via a free radical mechanism in the presence of peroxides. Terminal alkynes are acidic. Because of the 50% S character in their sp hybridized carbons, the shared electron pair in the CH bond is pulled strongly toward the carbon, facilitating the release of a proton. To be aromatic, a structure must meet three criteria: complete planarity with sp2 hybridization, a loop of overlapping p orbitals for cyclic conjugation, and a Huckel number of pi electrons. Benzene resists addition reactions. Instead, it undergoes electrophilic substitution reactions. These reactions involve various reagents to introduce substituents onto the aromatic ring. Substituents influence the direction of future substitutions. Ortho and para directors activate the ring via resonance. Conversely, meta directors are deactivating, directing incoming groups to the meta position. Certain polynuclear hydrocarbons are toxic and carcinogenic. Formed during the incomplete combustion of organic materials, these compounds can enter the body and cause severe DNA damage. In summary, this chapter reviewed hydrocarbon classification, isomerism, reaction mechanisms, and environmental impacts. Focus your board preparation on electrophilic substitution mechanisms and directive group influences. This video used resources from Indigo Instruments. Thank you for watching.